ALCF. I'm going to focus basically on how you actually use the SN30 data scale cluster in the AI testbed at ALCF. And I'm just going to, the slides will be public, so you can look at these offline as well. First, a system overview, then how to get account access, log in, how to set up virtual environments if necessary, and workflow that Craig has already described, but I'll show some examples live as well. So we have, this has already been said before a few times. So we have 64 RDUs spread across 8 nodes in 4 racks. And you can see the naming convention. There's a rack code. Racks run from 1 to 4, and then each rack has 2 halves, half 1 and half 2. And in fact, those names are the names that you use when you're SSHing to the nodes from the login node. First thing you have to do, if you haven't done this already, you don't already have access, is to request an account. This is done at HTTP. This is done at the accounts login page, https:/accounts ALCF.gov. You can see there's a request an account button on the left. Once you've requested an account and you've gotten it, then you log in and you end up with a different screen. You need to join a project, join the SN training project in this case. And then you need to also in one of the menu items on the left, you need to make sure that you actually have access. So you request and view systems and make sure that SambaNova is in the list. And the login is a 2-step process. You log in to a login node. And this is a round-robin login node, so it'll drop you on one of the 2 login nodes. And then from there, you log into one of the SambaNova nodes. And then at that point, you have access to Slurm and SambaNova stack and all. The initial login is using a mobile pass or a token code as the password, and then from there you have no password needed access to the various nodes in the rack. So for instance, in this case, you're logging into SN30 R1 H1. And the base environment is enough to run at a lot of samples. You'll probably end up wanting to create your own virtual environment. SambaNova uses the standard Python virtual environment, support no conda, and the instructions are here, but it should be familiar to people as well. And you just pip install whatever Python packages you need. The workflow, as described earlier, is 2 parts. The first part is compile, that produces a binary that's mapped to the RDUs. And the compiles are cached, sort of. The recompile only happens when the model parameters change. And you can see significant compile times for large models. That's why the SambaNova has introduced the various optimization levels, so that you can do your more rapid iterations at a lower optimization level, like 0.0 I think it was. Once you have a path file, you can run it, and you run it. You run it under Slurm with srun, and in this example, it doesn't have any parameters other than run and what the path to the path file is. So the examples in the current SambaNova examples are available on each node, and they're in /opt/sambaflow/apps. And you can inspect that tree for various examples, and sample code if you're interested in figuring out how to do something. There are lots of examples in there. The scripts to run these samples are in /data ANL scripts. It's a big directory, but you can find things by name fairly straightforwardly. I'm going to show this live, but this is basically, well, I'll show this live later, but basically what you're doing is you're running you're compiling a sample here and running the sample. We generally make a copy of the apps directory into the home directory so that there aren't no write access problems. And you can, and there are other examples as well. I'm going to show that one live as well. I'm going to show that one live as well. This slide shows how what the script does under the covers. You can look at the scripts as well. The command lines can be fairly complicated to deal with. Once you have them working, though, they're not a problem. So this system uses Slurm for orchestration, and the two commands that you need to know are srun. Well, 3 or 4 commands you need to know. srun and sbatch are for launching jobs. sq is for checking the current status. sinfo will give you the cluster status, and scancel will let you cancel a job. There's also an sn_tilestat, which is a SambaNova command that shows you the status of all the RDUs on the node that you're logged into. Let's see. So there are some links here, and if you have the slides, you'll be able to click on the links there. The local paths of interest are ops SambaFlow apps and /data/ANL scripts. And also we've cached some standard data sets in /software SambaNova dataset, and /software/projects and /projects are places that have more storage space if you need it. Let's see. Available for director's discretionary allocations. So now I'm gonna try and show a live demo. So first thing is login. Now, since I've got other sessions logged in, it's not asking me for my mobile passcode, but it would normally the first time you log in. And then log into a particular node like so. This is just a random node. Conda for another system. I'm going to deactivate it. And I'm going to copy the application tree locally. This takes longer than I thought. And you know, activate the virtual environment for this particular sample. Some of the virtual environments are pretty much identical to the base environment, but it's good practice to do this. And I'm going to change the sample directory, the forward network MNIST sample. MNIST is a character recognition data set that is basically the basic sample for most AI hardware systems. And do the compile. The compile, I believe, on this machine is cached, so it may proceed quickly, hopefully. And there's a lot of compiler output, as you can see, including warnings of various sorts. But only errors will give you complete failure. So. And you can see that the compile produced this particular PEF file in this directory. And in fact, in that directory, there's a lot of stuff that a lot of file artifacts. You can browse them if you'd like. Let me show you. That's for a small sample. But you can see the PEF file here and some CSV files and some scripts, all sorts of things. Let's see. So here's running a sample. It's using the PEF file that was just generated. And looks like a batch size of 1. And it's running this sample in run mode. And it's running it under Slurm, which will, by default, allocate you 1 RDU on 1 node. And here it is executing. The framework provides a whole bunch of default options that you can see listed up top. I was making progress when I tried it earlier. So it looks like it decided to output everything all at once. So you can see it's running a small epoch and this thing isn't outputting any. It's outputting the loss and the accuracy and such. There's also a log file that you can look at. That's the most basic sample. And if you can get that working, then you can proceed to other samples. So next one I'm going to show is the GPT-2. And so I'm just making a directory dedicated for this and copying some scripts. And making sure it's executable. And this one actually takes a while to compile, so hopefully this is cached. It was cached earlier, so it probably still is. This particular script will run the sample after it compiles it. And the 32 is the batch size. And it's created a Slurm job. So I'm going to put this in my history here. You can see it's running. You can see a job here, also a test job, but you can see the GPT job that's running. And there's also a SN tilestat command that will show you details about the actual hardware usage. And if you have a running job, and by default, these scripts will drop your job on the current node if there's space. So you can use SS and tilestat to see what the usage is. There'll be a lot of details in the output. And you need a much wider screen to see it in columns, but you have things like the execution percentage, the command, who's doing it, etc. And these are all already used that aren't being used on a node. So here's the job. And you can see it's training at the moment. And it's outputting output every step. You can see these steps per second and various other statistics in the output here. There's also often a summary at the end, depending on the sample. This is a 1.5 billion parameter GPT-2. It's GPT-2 XL, I believe. And because things are running on a local machine, you can look and you can see your process running. With multi-node, that can be a little more problematic, but when you're debugging and developing, working within a single node can be helpful. Vernie, do you remember how many steps this runs? Should I just break out of it?
Yeah, I think it's good enough. It says it's 60, around 70 out of 750K. So
I can just cancel a job.
75K, so you can
Let me show
just
you how to cancel a job.
yeah, that would be a good one to show.
So if you're bored with the execution of a job for whatever reason, you can cancel it. You just need the job ID, like so. Hopefully that'll, yeah, I canceled it. So that's a GPT-2 sample. I think that's probably enough.
Okay.
Let me show you one more thing.
Could you go over the documentation on the website? Just
Yeah, I'm just bringing that over right now.
okay, thank you.
Let's see. So we have put together documentation on this on the various AI testbed systems. The documentation for SambaNova is here. This is docs.alcf.nl.gov, and you can navigate from there. The doc. Most of what I've covered here is identical to what was in the slides, but in more detail. Also, the documentation we test every release, so it should be largely usable, and commands that are in it you should be able to copy and paste to the command line. We've included also a section on tunneling and forwarding ports and use of SambaTune, basically how to assemble the tunnels for doing that. And then there are some other items and examples on running things on multiple nodes. And the example program covers more samples in the SambaNova SambaFlow apps directory as well. So we strongly recommend that you look at this documentation mainly because we try and keep it accurate. And it also has good deal more detail in the slides. I think that's it. Attorney.